So we are going to discuss how to find the last two digits of a power b. For example, a number is given to you like this, 273 power 273. How to find the last two digits? This is a very important question, standard question which is repeatedly asked in every competitive examination. Now, let us see the case of a power b. And before getting into how to find the last two digits, we'll just discuss how to find a unit digit. Let us take the case of 273 power 273. The unit digit of this number will be determined by the unit digit of the base and the last two digits of the exponent. This is only for finding the unit digit, right? So this particular number will have the very same unit digit of 3 power 73. Now, the next step is very simple. Let the base be as such, and the exponent is to be divided by 4, and the remainder we want. So when 73 is divided by 4, how much is the remainder? The remainder will be 1. So this will have the very same unit digit of 3 power 1, which is nothing but 3. So this is the shortest shortcut, in fact, and there is some underlying logic here. So I'll explain it in a different way. So 3 power 1 is ending with 3, 3 power 2 ends with 9, 3 power 3 7, 3 power 4 1, and 3 power 5 3, 3 power 6 9, 3 power 7 7, 3 power 8 1, and so on. So what do we understand from this? After 4 numbers, the same set of numbers, the unit digits are getting repeated again and again. So that is why we must have to go for dividing the exponent by 4, and we will be arriving at the remainder. Now listen carefully. Since after 4 calculations, the reminders, the unit digits are getting repeated, we say that the power cycle of 3 is 4. For how many digits the power cycle, starting from 0 to 9, we have got 10 digits. So for how many other digits the power cycle is 4, if you just go for a calculation, you'll find that for 2, 3, 7 and 8, the power cycle is 4. And similarly, the power cycle is 1 for some of the numbers. So number ending with a particular digit, whatever be the power, it will not undergo any change. The unit digit will not undergo any change. So the numbers are 0, 1, 5 and 6. So for the other two digits, 4 and 9, the power cycle is 2. So this you must start to memorize if you want to proceed further. Very important. Now what we are doing is, now we are getting, we are going to calculate 3 power 73. Listen, this particular, we have to look at the power cycle of this particular number, the unit digit of the base. So what is the power cycle of 3? It is 4. So the exponent is to be divided by 4, and we must start to arrive at the remainder. So 3 power 1 will give you 3. For example, 9 power 27. If you want to find the unit digit, the power cycle of 9 is 2. So this particular exponent is to be divided by 2, and we must have to arrive at the remainder. So this will have the very same unit digit of 9 power 1, which is nothing but 9. So this is how we have to find the unit digit. But as I told you, you can always go for division by 4, the shortest method. Now we are going for calculating the last two digits of a power b. So before going for solving this problem, let us look at some of the basics. Let us say the case of a is equal to, a can be equal to 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. If the a ends with 0, we have got a shortcut, because any number ending with 0, power something, will give you the last two digits 0, 0, as long as the value of x is not 0 or 1. No issues. So if the base ends with 0, the problem gets simplified. So let us not worry about this. And if the base ends with 5, for example 25 power 44, how to find the last two digits? Listen carefully. If a number ends with 5 and the exponent is an even number, this will always end with 25. And if a number ends with 5 and the exponent is an odd number, right? Now, this particular number can be ending with either 25 or 75 only. There are two options. So, there is a shortcut for this also. Just see whether it is an odd number or even number. If it's an even number, okay, it will be ending with 25. If this is an odd number, just look at the tens digit of the base. If this is an even number, this will be ending with 25 only again. And let us take the case of 35 power 43. This is an odd number and the tens digit of the base is an odd number. In such cases, it will be ending with 75. So, this is a logic which you have to apply for value of A ending with 5. So, this also we have seen. Now, if the value of A ends with 1, we have got a shortcut. For example, 21 power 43. You can easily calculate the last two digits. The unit digit is 1, is known to everybody. And if you want to calculate the tens digit, you must have to go for multiplying these two numbers. The unit digit of the exponent and the tens digit of the base. What is 2 into 3? 6. So 61 will be the last two digits of 21 power 43. So whenever the unit digit of the base is 1, you can apply this logic. Right. Now, we are going to discuss a method, a common method. If the value of A, if the base ends with 3, 7 or 9. Listen carefully. Before going for this method, I just want to make certain things clear. As a person preparing for a competitive examination, you are supposed to memorize squares of numbers up to 25. Right? If you memorize squares of numbers up to 25, squares of numbers up to 125, you can easily calculate without any difficulty within 3-4 seconds. Listen carefully. Supposing that you are memorizing this. So this is 26 to 50, 51 to 75, 76 to 100, 101 to 125. And I am going to teach you a method through which squares of numbers up to 25 can easily be found. Now, since these two sets of numbers, since these two buckets are closer to 50, write 50 here. Since these two buckets are closer to 100, write 100 here. Now, let us, before that, as far as these two buckets are concerned, number 25 is an important number. As far as these two buckets are concerned, the number itself is important. I tell you what is that. Listen. Now, let us take the case of 48 squared. Now, 50 minus 48 is how much you have to find. What is 50 minus 48? 2. What is 2 squared? 4. You write 04 here. For square of the difference between these two numbers, 2 digits are allocated. That is why we are writing 04 here. Now, how much is the difference? Difference is 2. This 2 is to be subtracted from 25. What is 25 minus 2? 23. The answer is 23. 2304. Similarly, 41 squared. Now, the difference is 9. 9 squared will be 81. And 25 minus 9 will be 16. So, like this you can proceed. Here you are subtracting the difference from 25. In this case, you must have to go for adding the difference. Other than that, it is one and the same. Now, listen carefully. 57 squared. 57, the difference between 50 and 57 is 7. 7 squared will be 49. And 7 is to be added with 25, will be getting 32. So, 57 squared is 324. Now, 61 squared. The difference is 11. 11 squared is 21, carry 1. And this 11 is to be added with 26, 25, 36. Plus 1 will be 37. Now, coming here. 94 squared. Difference between 194 is 6. 6 squared is 36. And the difference of 6 is to be subtracted from the number itself. Here we have written the number itself, right? So 94 minus 6 will give you 88. And 88 squared. The difference is 12. 12 squared is 44. Carry 1. And 88 minus 12 will be 76. Plus 1 will be 77. In fact, this is a very fancy number. That is the only perfect square which can be written in the form XXYY. So there was a question on this in CAT 2007 also. We'll discuss it later. Now coming here. So this is here we are going for a minus. Here as usual we are going for a plus. 103 squared. So difference between 103 is 3. 3 squared will be 09. So 103 plus 3 will be 106. So this is how you must have to do this. Now, this is an interesting question. There was a question asked in CAT 2007. Find the perfect square which can be written in the form xx, yy. Now, we have memorized squares of numbers up to 25. Which perfect square ends with yy up to 25 square? So there are three numbers. Which are they? 100, 400 and 144. Right? So 100 and 400 we must not ignore, because if you take that into consideration, we don't have a perfect square. We don't have a two-digit perfect square which can be written in the form xx. 16, 25, 36, 49, 64, 81. No two-digit perfect square can be written in the form xx. I have understood from this entire calculation. This entire calculation, what do you have understood? The understanding is, if x is a number up to 25, x squared, 50 minus x whole squared, 50 plus x whole squared, 100 minus x whole square, 100 plus x whole square, all these numbers will be ending with the very same last two digits. That's what we have understood from here, right? The same concept you can apply here also. Now listen carefully. Since this is ending with yy, the answer can be 12 squared, 38 squared, and 62 squared, or 88 squared. We can go for calculating the values of these four numbers, and we can just arrive at the answer. Even that is not required if you know one more concept. Is it divisible by 11? X plus y, the difference is 0. This is divisible by 11. Out of these numbers, which is divisible by 11? Only 88 squared. And hence, without even calculating what is 88 squared, we can easily arrive at the answer. The answer is 88 squared. Right? Okay. This particular question has nothing to do with our calculation, but this concept only we are going to use in our calculations. X square, if x is a number up to 25, x square, 50 minus x whole square, 50 plus x whole square, 100 minus x whole square, all these numbers will be ending with the very same last two digits. Now, listen, I will just, I'll just tell you a method how to arrive at the last two digits. In the case of the base number ending with 3, 7 or 9. Now, let us take this very same example. In the case, when you go for finding the last two digits are determined by the last two digits of the base and the entire power. So this particular number will have the very same last two digits of 73 power 273. Now, what is the power cycle of the unit digit 3? What is the power cycle? Power cycle is 4. Now, write 73 here, right? Power 4 here, and 273 is to be divided by 4. What is the quotient we have to calculate? Quotient is 68, right? And how much is the remainder? Remainder is 1. So dividend is equal to divisor into quotient plus remainder. Nothing but mere simplification only. Now we are going to calculate what is 73 power 4. So 73 power 4 is nothing but 73 squared whole squared. So 73 squared, as per the logic which we have seen so far, will have the very same last two digits of 23 squared. So 23 squared is nothing but 529. Let us write the last two digits, 29 squared. Now 29 squared will have the very same last two digits of 21 squared for obvious reasons. So 21 squared is nothing but 41. Write 41 here. So instead of 73 power 4, we can write 41 here, power 68 into 73. So when a number, if the base ends with 1, we know the shortcut. Write 1 here, unit digit will be 1, and the tens digit will be 4 into 8, 2 into 73. Now we will go for multiplying this. This is 3, 6 plus 7 is 3. So the last two digits of 273 power 273 will be 33. Okay. This is how we have to calculate for numbers ending with 3, 7 and 9. Now even this is not required. This is only for beginners. Whenever a number, whenever the base ends with 1, 3, 7 or 9, we can apply this logic. We can very well divide the exponent by 20. The remainder only we can write. For example, 73 power 273 we are interested in calculating, and since this is ending with 3, one of these 4 numbers, what you can do is 73 power, this exponent 273 should be divided by 20, remainder will be 13. 13 you write here. And we'll proceed further from here. So 73 power 4 power 3 into 73 power 1. So 73 power 4 we have already calculated, this is 41 power 3 into 73. This is nothing but 21 into 73. This is nothing but 33. You can calculate this way also, right? So for 3, 7 and 9 we have seen a method. Now which are all the other digits that are remaining? 2, 4, 6 and 8. If the base of this particular number ends with 2, 4, 6 or 8, then how to do this? That we'll discuss in a different way. Before going for numbers ending with 2, 4, 6 and 8, I'll just show you how to find the last 2 digits of a power of 2. Let us take the case of 2 power 44. We have to find the last 2 digits of this number. So 2 power 44, before going for this, we must have to understand one important concept. 2 power 10, power an even number will end with 76. 2 power 10, power an odd number will end with 24. This concept we can apply here also. So 2 power 10, power 4 into 2 power 4. 2 power 10, power an even number is nothing but 76. Into 2 power 4 is 16. When you go for multiplying, you will be getting 16. So answer is 16. But you may be wondering how I got this 16 immediately. Whenever you go for multiplying a multiple of 4 with 76, the last 2 digits will not undergo any change. Whenever you go for multiplying a multiple of 4 with 76, the last 2 digits will not undergo any change. It is not only in the case of 76, in the case of 0, 1, 26, 76 and 51 and all, the same logic will apply. Right? Here we are getting only 76, so we are using this. So let us take the case of 2 power 41. Let us find the last 2 digits. 2 power 10 power 4 into 2 power 1. 2 power 10 power an even number is 76 into 2. Since this is not a multiple of 4, you can't simply write it as 0, 2. You must have to multiply. So what is that? So answer is 52. Now 2 power 34, we'll calculate. 2 power 34 is nothing but 2 power 10 power 3 into 2 power 4. 2 power 10 power an odd number will be 24 into 16. We just multiply, this will be. So for powers of 2, we have got a simple method. Using this concept, we can find the last 2 digits of a number in the format a power b. So let us take the case of 68 power 24. Since this number is one among 2, 4, 6 and 8, whenever a ends with 2, 4, 6, 8, this logic can be applied. So you just keep on dividing by 2. 68 by 2 you are getting 34, and again by 2, 17. So this is nothing but 2 power 2 into 17 power 1 power 24. So 2 power 48 into 17 power 24. 2 power 48 is nothing but 2 power 10 power 4 into 2 power 8. This is 17 power 4. The power cycle of 7 is 4. 17 power 4 into power 6. So 2 power 10, power an even number will be 76. 2 power 8 is 256, right? The last 2 digits 56. And 17 power 4, what is it? 89, 11, 21. 21 power 6. So when you multiply, since this is a multiple of 4, when you multiply with 76, the last 2 digits will not undergo any change. 56 into 1, 2. So 6, 5 plus 2 will be 7. The last 2 digits will be 76. So this is how we have to proceed. So let me summarize. In the case of a power b, if a ends with 0, the problem is solved. It will be 2 zeros as long as the value of b is 2 or more. And if it is ending with 5, what is that? If the exponent is an even number, this will be ending with 25. If the exponent is an odd number, look at the tens digit of the base. If it is even, the number will be 25. If it is odd, it will be 75. Right? So for 1, we know the method. What is that? You write the number here. Unit digit will be 1, and tens digit can be found by multiplying these two numbers. So that is what we have done here. And in the case of numbers ending with 3, 7 and 9, we must have to go for writing it this way, right? This particular exponent is to be divided by the power cycle, and in this particular format you must have to write this, and you must have to proceed. And in the case of powers of 2, you have got a different logic. 2 power 10, power an even number will be 76. 2 power 10, power an odd number will give you a number ending with 24. And using that concept, we can solve these questions also.